Hey everyone, Brett with B&B Dynamic Machining. It's a nice collaboration meeting. Cayle from Ram Precision is nice enough to go over some shortcuts that he uses on the Haas controller. I'll do a little zoom in on what he has up on the controller right now, but first I'll let Cayle introduce himself real quick.
Hi, I'm Cayle Hammond. I'm from Ram Precision. I'm a manufacturing engineer there. I mostly work in milling, trying to get ourselves as efficient as we can. So I have some crazy ideas to show on here tonight.
So like I said real quick, this is what he's got. And he's going to do some tool presetting. Instead of going in the offset file and typing in some stuff, he likes to do it this way. So Cayle probably won't be on camera. We're going to try to show more of the controller. I'll let Cayle take it from here.
All right, yeah, so normally we're touching off tools and we're going in, filling out the approximate length and the approximate diameter and how we're gonna probe it. So after a while, I got kind of tired of doing this all the time. So I wanted to make sure that if we ran a job, that all this was kind of pre-populated. So it took me a while to figure it out, but if you go in, you can automatically touch off the tools. And then one of these options is to probe all the tools. And when you do that, it actually writes into the MDI. In fact, I think I can do that here. No, I'd have to hit go on it. Let me just do that real quick. That's gonna screw up here. I don't wanna screw up Brett's stuff here. But when you do that, it writes into MDI, and that's where I got this idea from. So it writes out all the tool touch-off commands in here, and it has tool changes in there, so it can go through, it'll go down your list and do each tool one at a time, putting in all this. So this is all written out, but I thought if we did this, we could put MOs in here, so when it does the tool 20, it'll pull up tool 20 and then stop and wait for me to either load the tool in there or make sure it's in there, and then I can hit cycle start, and then it'll do the tool touch off, which is written in there. So everything you're filling in here is basically converted into the code. And I have a little cheat sheet here for you guys. I can share that online too. And it just tells you what everything is here. So your approximate radius, we use radius at RAM. You're using diameter here, so this would be the diameter. But the D is that diameter. The E is the approximate length. The K is how far up on the tool to pick up the diameter. Brett, you said you don't pick up diameters, right? Because you do wear comp on your...
Yeah, I don't usually do diameters.
So, you know, Brett would do it a little bit different than we're doing it. We are picking up the diameters of the tools. So the C3 is the probing type. So if you do F1 here, you get your different probe types. C3 is length and diameter probing. C1 would just be probing a rotating tool, so an insert tool, for example. So you want to find that the highest insert, and then C2 would be like picking up a drill or a spot drill, or in your case, you could use C2 for most of what you do until you get to a bigger size where you want to pick up, you know, like if you have a 2-inch end mill, you want to pick up the outside.
Yep.
You don't want to pick up in the center, which is what the C2 is going to do. So that's where some of these numbers come from. Like I said, I have a cheat sheet for this. So the first one, I have tool descriptions in here from what we use at RAM. Again, we're at Brett's machine here, so he's got a little bit different in here. But I even go in here and write down, you know, what's the tool number? In this case, I can use a used end mill. So if we have something that we know is used, we have them separated from the new ones. So now I'm not using a brand new end mill on this because I don't need to. But I'm putting that right in my notes, so whoever's setting this up knows that without asking anything. The part numbers are there to verify that you're getting the right tool. And we have a pretty standard setup. We have ER32 collets, and we also have the mill chucks, and it's pretty standard. I will say that the worst thing that happens here is either it swings and misses, it's not long enough, or it hits early. Both will air out in the machine. It won't do any damage to the probe. So if your E number is off a little bit, it's not a big deal. So let's say, Brett, you have a longer holder than I had. It's going to touch sooner than it should. The machine will say unexpected surface found. Mm-hmm. So then you would just come in and change that E number and run it again. Okay. So it's pretty easy. Sometimes it's hard to figure out what it needs to be, but we're pretty consistent in how we set up, so the numbers rarely change. I'll say, maybe once a week we have to change an E number, so it's not too bad.
Yeah.
The really good part about this is it kind of gets you through a process of how we're going to set up this job. I have these in order. It's 20, 21, 22. It doesn't have to be in order. The machine's gonna give me the pocket for T21 into the spindle, so I know I'm putting T21 in there when that is up in the program here. There's a few things you could change in here if you want to. We have MOs before and after, so I just want to make sure that after it touches off that it stops and waits for me to change the next tool. If you don't like that, you could always do an M1 in there, then you have the option of turning optional stop on or off, maybe make it a little more efficient for you. I just like seeing it that way. Honestly, it's because we've always been doing it that way. It may not have been the best choice, but it's been that way for a long time now. The other thing would be putting the tool description down further, like after the MO, because when it does the tool change, it would highlight that then. So it's easy to see, all right, well, tool 21 is in the spindle, and I need to be putting in the spot tool. So it's highlighted in orange as it goes down. But yeah, you can play around with how you do this by what you want to do. You can see the block skips on the side here. So when you're done with a job, especially in this, how many tools do you have in this one?
30.
30
Plus
tools?
The Pro.
So maybe I program this, this is a job that we throw in here real quick. When somebody needs 2 parts or something, we could throw it in. So we're gonna use tools, well, here's a good example, 20, 21, 22. So if I don't know that, when I'm done with the job, I wanna get all the tools that I just put in there out. So I could do block skip, run this again, and all it's gonna do is do the tool changes with an MO in between. So that brings you tool 20, you could take it out, hit cycle start, get tool 21, take it out, hit cycle start, tool 22, take it out. They don't have to be in order, but if you go through the whole list, you get out what you put in. So you're kind of clearing out your machine properly. The other thing you can do there too, which we don't do, and it's a little hairy, but if you're good with it, you can actually go in. I'm just gonna go over to the actual numbers here. So these actual numbers are variables inside the machine. So let's say we took out tool 22. When we do that, you can have at the end of the program here, you can actually block skip your M30, go into another section of code that will go in and clear out the lines for you. So these 3 tools, you could clear out those 3 lines only, just so they're out of there then, so you don't get confused if you touched off the part or not, or the tool. Does that kind of make sense?
Yeah.
Okay. The big thing with doing it this way is you can do these variables. So you can see here, this variable 2221 on the Haas is the length wear column. So this is a spot tool. I always program, when I do my programs, I program to the virtual sharp point of the spot tool. They're not always sharp. So I always put in a 20 thou height comp. So that's gonna leave my tool up a little bit so that I'm not going too deep. Because as soon as you go too deep, you scrap the part. So this prevents us from doing that. I am terrible at remembering stuff. So it's a great way to not forget to do that and not scrap a part. Now you still have to make your adjustments to get the actual number in there, but at least you're at a good starting point. This is good too for, I don't know if you have any insert like countersinks or anything that has like a really big radius on the bottom.
Okay.
We have some. One of ours, we lasered on it actually. It's 108 thousandths from the virtual sharp to where the actual tool is. Yeah, so that one will scrap apart. So that one I'll put 130 thousandths in instead of 20. But I have that and I know that, so when we run that job again, it's automatically in there. This is, I didn't mention this, this is always at the top of our programs. So it's another subsection of the program that we're using at the very beginning. And then normally in a program, I'll just do a go-to, and then I'll jump down over top of this. So when you're running the job, you're not running through the tool touch-offs. Obviously, you don't want to do that. But you can always jump down. I don't know if I have... I think one of these has it. Yeah. So here's a good example. So this is just one of my other ones that I have some variables in. We'll talk about in a little bit. But you can see the tool pickup and load is down here. So let's say my tool 17 broke. I could just type tool 17 in memory and then hit down. It takes me right to that spot in my tool loading. So I can easily just get that tool into the spindle, take it out, put a new one in, and then run the tool touch off again. So it's just a quick way, because it's at the top, it's the first T17 that the search will see. The other thing I do too is I do N999, so we're consistent, but then that's always at the top there. But you can see my go-to here. So when we're running this program, it hits the go-to one and it jumps down over top of the tool touch off. Does it kind of make sense?
Yeah.
Okay. You guys have any questions?
Yeah.
All right.
Good.
Let me just go back to that other one. I should have given them better numbers, sorry. I'm trying to think. So along with the 20 thousandths and the height, let's say you have a really tight tolerance. We do a lot of tight tolerance. We were just talking about that in the office. So I can't afford to be off a little bit on the diameter of the tool. So what I can do is, instead of 22, let's do it on this one here. So after I touch it, and this is important, you have to do it after you touch off the tool. You want to put that in there, because if you do it beforehand,
It's gonna wipe
it'll
it out.
clear it out. Right. So if I do pound 2620, so 26 is that last diameter wear column. Like I said, I have a cheat sheet there. And the 20 is the tool number. So the last two digits are your tool number, and then the 26 is that column. If you get over 100 tools, then you go to 2700. But that's in there too. Yeah, I don't get into 100 tools. So we're gonna make that equal to, let's too many zeros. I'm gonna put a thousandths wear comp on there. And I'm just gonna put my block skip in front of there. I forgot that, but that way when we unload the tools, we're not writing it back into there. Just in case, you're running through and you wanted that number, you don't lose it. So when you run this single line of code here, I'll just single block this. I don't like running other people's machines, but Brett's awesome, so. So I'll run this single line of code here. It still says the door's open. You said you don't need any info in tool 20, right?
No, you can wipe everything out.
Okay, so Brett already has minus 9/10 in here. Is it closed now? There we go. All right, so I just ran that one line of code to change the 2620 to a thousandths, and that's what it puts in that column. So this column starts off with 2000, this is 2200, 2400, and 2600. It's gonna be different on every machine. Brett, you asked me the other day about this. So timers and counters is touchscreen. All right, so if you touch the timers and counters here, you can assign macro variables to here. So let's just call this T20 dware. And we're gonna make this that same variable, that 2620. And now you can see that variable down here. So you can do this for a lot of things. The big one, and I learned this from one of the service guys, which is awesome. Oops. So I'm just gonna call this probe. Let's just code probe measure. So you can label these however you want. So when you probe something, it stores that measurement for a little bit, which is 10,188.
Yep.
And that's the last thing that you probed. Now, if you probe like X and Y, as soon as it probes the X, it'll quickly show that and then go away to do the Y. So if you want to store that, you can actually write it in your code to store that, but you've got to probe the X, store the variable, and then probe the Y, and then store the variable. You can't do the box.
We
Does
use
that
it a
make
lot
sense?
for diameters, check the diameters.
Yeah, that's what it's really good for. So we have it up here almost all the time.
Yeah.
The only time we don't have it up there is when we're doing like diameter wear, and this is pretty cool too. Like I said, we go in small numbers. Let's say you got to move this 20 millionths. So I'm going to add 20 millionths. It doesn't show me 20 millionths there. It shows me 20 million's down here though. So you got more decimal places down here?
So I can't believe you guys worked to that.
Yeah. So we have more decimal places down here than you do up here. And what happens is, like, I'll add another 30 millions. So you can see this jumps to 11. Sometimes it does, sometimes it doesn't. I don't think it's consistent on how it is, but it could be a rounding with converting to metric or something in the background. But this is very handy. We use it a lot. The only bad thing is there's only two spots to use. So you kind of have to pick the ones that you need for the job you're doing. But one of the ones we use this for is something we run a lot of. And it's that one I was telling you about where I actually have the program keep compensating, and I want to see where we are, because once I get to about 3,000, we're replacing that tool. So I can keep an eye on it there.
That makes sense.
So, but I also have a check in the program that if this 2620 number gets over 3,000, to alarm out and let me know that it's too much. So that way we're getting good use out of the tool, but we're not pushing too much. I'd rather change out the tool at that point and keep running. So yeah, that was the one thing you definitely wanted to see, right?
Yep,
So,
absolutely.
Yeah.
Thank you.
I guess we could. You have something in tool 20?
Yep.
So let's just
Half-inch
reset this.
OSP mill.
All right.
Don't hit the park.
So you have it. I know.
I know it clears already. Trust me.
You're scaring me. Yeah. All right. So he has a drill in there. So I'm just going to go in here and change. So while I'm going through
It's
these.
actually an end mill. I'm telling you.
Oh, it's an end mill?
Yeah, half-inch
Oh,
end mill.
I'm
OSP
sorry.
mill.
I thought you said
Right.
drill. So
Drill
half
would-
inch.
Drill would be 22 if we want to put that in.
Okay. Well, yeah, that's what I have for there. So, so I just changed the diameter to ½ inch. Do you know approximately how long that is?
It's probably going to be in there.
Oh, from before.
Yeah.
All right. So 5. All right. I'm gonna be.
4.5. Or no, yeah, I'm sorry. You were
It's 5.1. So I'm gonna say 5. You really don't have to be all that accurate here. I don't know the exact variability that you can have, but I'll be honest. We put 3.5 inches in all the time, and it almost always works. So the good thing with drills, you don't. Anytime you're doing the C2, which is basically the drill touch off, it's just coming down and touching. It's
Yeah.
not stopping a ½ inch. I don't know how yours does it, but mine stops a ½ inch before and then spins backwards to touch.
Yeah.
So on the drills, the estimated length means absolutely nothing.
Okay.
Which is nice. In our Makino, we have a Renishaw in there as well. That one actually runs the drill program first, gets an approximate length on the tool, and then it runs the other, the diameter and the length. So yeah, it's pretty nice, and I could probably make this one do it. It's just, for what we're doing, it's not worth trying to change the Renishaw code or using a different code. It's probably what it is. It's just a different code. All right, so I changed that. So we'll start at the beginning here. So we're gonna start touching our tools up. It's making noises.
I'm on single block.
Ah, jeez. At least in a single block and I didn't break something. All right, so you guys can't see, but this just gave us our tool 20. That's tool 20, right?
Yep.
Actually, we could see it up here. It's tool 20. So now it's waiting for me. And this is where I was talking about, if you want to have this highlighted with what tool you should be putting in there now, it's probably a good idea. So you can move this description down past the M0 line. Does that make sense?
Okay.
Let's actually just...
Sorry.
That's all right. We're just going to do that.
That way you can actually see.
Yeah.
The highway. Pretty nice.
There we go. Now, so I can just copy that down, and we'll put it right here. Alright. So, we're already making updates to what we were doing, so this is why I wanted to show this stuff, kind of bounce ideas and get different ideas from everybody. So we'll run this again. Now obviously tool 20 is already in the spindle, so it's just going to jump down and wait for us, which is what we want. But now this is nice because it highlights exactly what we should put in there. It's not your OSG, but it's whatever I copied this from. That's actually one of my favorite end mills that we use. It's a helical. They work really well. So.
It's not an Amazon tool.
No, it's not an Amazon tool. Yeah, they're inexpensive and they last a long time, and that's why a used end mill is okay. Is we use a ton of them on some hard milling, and they get put in a drawer, so we have hundreds of them available for use for stuff like this.
Nice.
All right, so now. So now we're going to go into the touch-off routine. And I'm going to watch that I don't hit anything in this machine. All right, we're good. Yeah, the worst is the fly cutter that we have, making sure that misses the corner of the vise.
I'm not gonna lie, when you came in here, dude, it was a good thing you noticed that the presetter was rotated.
Oh, yeah. That was last time, right?
Yeah, when we practiced.
Yeah. All right, so we're about a ½ inch above, and it started the spindle. So this is exactly what mine does too. So it's going to get the length here.
Now, is this doing length and diameter?
Yes. Okay, making sure it doesn't slam into your part.
That's what I was.
Yeah, your touch off is a little bit, it's rotated 90 from the way ours is too.
Gotcha.
But it works. So I'm just going to go to the offset page here. So I will tell you one thing that can be a problem, but it doesn't matter if you do it this way or if you fill out that. I don't know if they fixed it or not yet. So you don't do this, so you don't normally have the diameter in there, right?
Nope.
And it just went to tool 21. That's what that noise was, right?
Yeah.
Okay. But again, we put that 1 thou wear in there. So now we could tweak our part in, and we could be within tenths instead of thousandths, right?
Mhm.
Right, Brad? Oh, you said about putting the number of flutes in too. So the number of flutes is pound 16. Is this a 3-fluter?
Yes.
It is, okay. We can just, I'm gonna reset this. I'm just gonna change this to 0. Would not let me, oh, you can't do 0. All right, do you have the coolant, programmable coolant on here?
No.
You don't, okay. Because that's another one. So when you zero out this table, you know how you can origin and zero out everything except for the probe? Don't forget not to zero out the probe. There, on our machine, we have a programmable coolant nozzle, and that has a number similar to this. That's why I was trying to go to 0. So it goes from 0, I don't know the highest number, but basically it zeroes it out every time. And this I'll have to set this up if you guys need to do this, but we took our shortest tool and our longest tool, and I got a linear equation, and then in this touch-off routine at the very bottom, I take this number for the height, run it through that equation, and it gives me where to aim that nozzle.
Okay.
So if I touch off 18 tools, if you don't do that, it sprays it at the bearings on the spindle. It's way up the spindle. It's a pain in the butt. So instead of doing 18 times of waiting for the tool to start and then bringing it down and setting your number, we did that. And again, it's one of those that we'll adjust it once in a while, but it's rare. I don't have any compensation for like a bigger tool, like a big shell mill.
Yeah.
So I'm just looking at length. I'm not looking at diameter too. It gets a little complicated the way that mechanism works. So it gets you close enough that you can move it 2 times and then set that number in there. But now, when you clear everything out, and what'd you say, 30 in this? 30 tools?
Yeah, plus
Okay.
the probe, yeah, 30.
So 31 tools. So you're not setting the coolant for 31 tools. You may be adjusting it on a few of them or all of them. It makes it a lot easier for that. So that's another variable that we can push into here. But that one I did go into the Renishaw program and edit that. So that is every time you touch off a tool, every time it gets this number here, it's writing that number in there. Not the flutes. Do you have? No, yours doesn't even have it, right?
No. No.
There's another column for the programmable coolant nozzle, and it's just 0 to 20. I'm guessing
Yeah,
at
it
the
does say
20.
coolant
I think
position
it's-
on the top too.
Yeah, it does. So maybe you do have it. No, I don't see it. I think you can turn them on and off. You think it's all the way at the end?
I don't think so. No.
Yeah, because it's one of those that you want to change all the time.
Yeah.
So when I was showing this to Brett, he likes putting the number of flutes in so you get your chip load, right?
Yep.
So that's another one that we could do. Actually, let me tell you this first. So instead of guessing at what variables are, because if you change a variable, I did it the other day, I changed my tool touch off variable, and it thankfully told me that it was out of calibration. But you want to make sure that you're looking at the right variable before you start changing it. So the easiest way that I've found is going into here. So we're going to look at this 1620 should be the number of flutes. So right now it says 1. If I go into our table here, so I'm just going to test this out. If I change this to 6, it didn't like the decimal point. If I change it to 6, it adds 6 because I hit enter. So now it says 7 down here. So these are tied together then. Okay, so then I know that, I forget the number already, 1620. 1620 is the right variable. So it's better than saying, all right, we'll just change 1620 to 3. Well, then 1620 is something else and you wind up crashing the machine. You don't want to do that.
At least I don't feel so bad when I forget something within 3 seconds.
Oh, you don't hang out with me enough then. So we're going to do 1620 equals 3 and the block. And I forgot to do the block skip again. Again, the block skip is just so you're not doing that when you're clearing out the tools. I'm just going to run single block on this one. So this one we should be able to see here. So you can see that changes that to 3. So now if Brett's going to use this, he can save all this data because he's going to use that same tool. He's going to put the tool number in here and everything. So he knows it's a 3 flute tool. So he won't have to add that next time or change it. Maybe it says 4 or 5 from something else and didn't get cleared out. Do they all go to 1 when you origin?
I've never origin.
All right, I'm going to origin. Not while the machine is running. So, all right, I'm going to be really careful here. So I'm just going to clear the row on 20 and we'll touch it off again. So we'll clear the row. I just want to see what happens here. All right, it goes down to 2. So it has a default of 2. So if you don't do this, it's always going to be 2, and that's not what you want. And you know, I don't do this on ours, so it's always 2. I should have known that. So our chip load is always wrong, you know, because it's never matched up. So I will eventually get into pushing this through to all of them as well, because I could pull that. I don't know if I said that when we were on camera or not, but I have a cam post that basically posts this out every time. So the cam program knows when how many flutes you have. It knows if it's a spot tool, so the spot tool automatically puts in the 20 thousandths in my post. So you can really program it so that you can post out a job that has 20 tools and you get this list out with the job posting. So you're not messing around with trying to type this out all the time. If you don't have access to changing your post and making that easy, you could always have like an Excel file that you could kind of fill out with your tools and then have that push out all these numbers. You know, so you could put in your diameter and then have that, put that in a code on the other side there. I can always make something if enough people want it. It's pretty easy to do. So let's run this tool 20 again now that we zeroed it out. So you never zero that out at all? No?
I'm always filling it out again. I just go on and fill it out.
So if you look at our machines, I mean, obviously this side's filled out, but if you look over here, this is all zeros and empty because we stopped doing this a couple years ago. I mean, like I said, it frustrates me to do the same thing over and over again. So plus I forget very easily, as you just saw. So that 20 thousandths, I don't know how many parts I scrapped that way. And I'm like, this is ridiculous. Why can't I just do this every time? And so finally fixed my memory. So we'll touch this off again then. But, oh, that's what I wanted to show you. Yeah. If you do origin this, you want to clear all except probe. There's 2 things that happen. First, you're clearing out your probe data. So you're losing your height offset, the height for the probe. So now you have to recalibrate your probe. But then it also turns off, I'm going to cancel this. And I didn't do this, but we found out the hard way. So it turns that off. That's how the controller knows that when you say clear everything except for the probe, it knows that's the probe, so it clears everything else. So if you accidentally clear it all, retouch off your probe and start doing stuff and then clear, it'll clear the probe again because it's not marked as a probe. So if you do that once, make sure it's marked as a probe so you don't do it twice. So long story short, we had to calibrate our probe like twice in a day because of that. So it was
I
not
leave
fun.
everything filled in because my philosophy is if it's not a special tool, I don't know if I'm going to need it again, so I'm leaving it set up.
And that works if you're going to use it because you're programming, you know what's in there. So
Just starting to agree with you.
yeah, see, we only have 18 tools plus the probe, so we're always pulling out the tools, so we're clearing it out. We've got some where like Op 1 is one program, and then we clear out all the tools, and then Op 2 is a different program because it's different tools in there. It just makes it easier. Like going through this is pretty easy, pulling them out and putting them back in. And that was the whole point. It's try to minimize the amount of time that we're spending doing, you know, stuff that doesn't add any value. Like I know putting all this stuff in here adds value, but if I could do it a better way, that's quicker, I'm doing it that way, so I don't have to waste my time at the machine.
Especially if you can have your cam posted out.
Well, that's even better, but I'm talking like repeat stuff is good this way too.
Yeah.
Not everybody has repeat stuff, but yeah, having it in your cam or like that Excel file I was talking about, it's pretty easy to make something like that, so you can make this quickly. I'll argue you could probably make the Excel file to do this more automated and make this before you can fill in that chart. It's not that hard to do this. It's probably about the same time to change all this as it is that, and then you have it for next time. All right, so yeah, I just wanted to warn you about origing that because that is a big problem, and we've had it before. I'll just go back over to here. All right, let's just touch off this one again. Not all that fun and exciting
Single
for
block still.
man. At least you're paying attention. Yeah. All right, so now we're looking to see. So it's coming down slowly. Yeah, you can't show in there, right?
I'm allowed to show pictures,
Okay. Nah. It's not that exciting. It's just touching a tool.
but yeah.
So we're looking to see. This is the other thing I want to warn you about.
There'll definitely be pictures on the website.
If you hit reset right now, you're going to have a 5" and a 1/2" on these two numbers. That'll crash. Found that out the hard way. So, you know, that's 122 thousandths off from what you think it is. It's a problem. So if you start picking something up, either finish it or go into here and make sure you get rid of it, because it will be wrong.
Okay.
Does it make sense? Yeah, we've had that before where somebody just reset and they started touching off again and didn't want to, so they hit reset and then they went and ran the job. Well, now it had 5" in there instead of 5.122. So it's a little bit of an issue. You just have to be aware that it can happen. So you see the 1 thou got in there, and then that changed to the 3 flutes. So,
Consistent too, except for 5016 again.
yeah, it's not bad. What do you have in 21? Yeah.
3/8 bull nose.
Okay. That'll work for what I want to show here. And you don't need this, you don't need these numbers for anything, right?
No.
Okay. So we didn't change this one to highlight the spot drill here, but you can see once I hit cycle start here, it should, see this one won't. Because this is a C2, which is basically like just coming down and touching length without spinning, it doesn't need an approximate length, so it doesn't overwrite that this time.
Okay. But it is going to add 20 in the length where?
Yep. So it's going to touch that off. It's a 1/10 different. And then once it hits the next line, it throws 20 thousandths in there. So this is our example of a spot drill or any kind of tool where you want to make sure that you're going to drop that down into where you want it to be, because you never know what that distance is. Ours are fairly consistent, so I know where to You know, we're around 10,000, so it's 8, 12, 10, somewhere around there. So if I'm going negative in here, I know there's something wrong, or maybe it's programmed differently than I thought. But it's a good way to kind of see what's going on. If you see it's still 20, you know that you didn't adjust your tool or anything. If you ever do any chamfering from the backside,
No.
okay. So I'm actually running a job tomorrow. I'll be doing this. I actually put a negative offset in there because I'm going through the hole,
Yeah.
and I want to be down more, and I want to creep in by coming up on that.
That makes sense.
So you could do the same thing here, but again, I have that in here, so when I touch that tool off, it's a specific tool that we have a part number on, and it has that -30 in there, so I'm always going deeper than I should be, which is keeping me material safe. I don't want to scrap that part. It's
Like
an
a Harvey
expensive
Tack
one.
camper tool.
Yes, yeah, exactly. So that offset it really comes in handy, as does the diameter wear as well. You guys can see where they both work. I can't really think of any other examples of that, but I mean, that's one of the biggest advantages of doing it this way. You have those, you know you got burned once making the part too small, so put in the thou on the wear comp so you don't do it again.
Nice.
All right. I'm gonna